Hello YouTube! So in this video we're going to talk about dialetheism and science. According to dialetheists, there are true contradictions. Most of the arguments for dialetheism appeal to semantic paradoxes like the liar paradox, the sentence, "this sentence is false." But in this video we're going to look at whether we might find support for dialetheism in empirical science. In fact, there's a fairly straightforward argument that science justifies belief in inconsistent objects. This is discussed by Mark Collivan in his article, "The Ontological Commitments of Inconsistent Theories." So, quick advert. If you like my channel, you can support me on Patreon or with a donation on PayPal. Anything really helps. I offer private tutoring in philosophy. Email if you're interested, and I have a Discord. The link will be in the description. Okay then, so the background here is that most philosophers are scientific realists. According to scientific realism, science aims to provide true descriptions of the world. We are justified in believing that our best theories are at least approximately true. I have a whole series on the arguments for scientific realism, which I'll link in the comments, but the standard argument for scientific realism appeals to the remarkable success of the sciences. Our best scientific theories make predictions of remarkable accuracy. Our scientific theories are used in the development of new instruments and technologies. So science is remarkably successful in a whole bunch of different ways, and the best explanation for this success is that those theories are approximately true. So most realists will make what Philip Kitcher calls the success to truth inference. The way Kitcher puts it is, if P plays an indispensable role in a systematic practice of fine-grained prediction and intervention, then we are justified in believing that P is true. And of course, if we're justified in believing that a theory is true, then we're justified in believing that the things postulated by that theory really exist. So, we're justified in believing in things like electrons, genes, black holes, forces, and so on, because these are postulated by our best scientific theories. As far as the realist is concerned, our ontological commitments, our beliefs about what exists, should be guided by science. Now, I think this is a fairly commonsensical way of viewing science. We believe what our best theories tell us about the world. But now, what should we say when those theories entail inconsistencies? I suppose, first of all, it's worth outlining a few different ways in which inconsistency can arise in science. So first of all, the most familiar kind of inconsistency occurs when there's a conflict between theory and observation. There are countless examples of this. Collivan gives the example of the galaxy rotation problem. So Newtonian gravitational theory plus our estimates of the mass distributions within disk galaxies imply that stars closer to the center of the galaxy will orbit with greater velocity than stars further from the center. So there should be a decline in speed as you move away from the center. It turns out, however, on the basis of estimations of speed from Doppler shifts, that many disk galaxies either have flat rotation curves or the speed actually increases the greater the distance from the center. So this little graph here shows the discrepancy. The line on the bottom is the expected velocity of the stars, but actually what we find is that the further you get from the galactic center, the greater the velocity. So here we have an inconsistency. There are three theories involved. So there's standard Newtonian gravitational theory. There's the theory involved in estimating the masses of the galaxies, which can be calculated from the distribution of stars. And then there's the theory involved in determining the velocity of the stars, which is that's calculated using Doppler shifts. Now, of course, we can try to resolve this inconsistency. The standard way to resolve it these days is to postulate dark matter. So the claim would be that we were wrong about the mass distribution within the galaxy, and there's actually a lot more mass there than what we might have thought on the basis of the visible stars. So, maybe dark matter accounts for this, or maybe our understanding of gravity needs to be modified, as proposed by modified Newtonian dynamics. The point for now is just, we have an inconsistency in three well-confirmed theories. Okay, so a second kind of inconsistency uh, arises when you have an inconsistency between two theories or models. A famous example is the conflict between general relativity and quantum mechanics. The development of a unified theory is one of the major problems in modern physics, but there are plenty of more mundane examples of this. We find this kind of inconsistency whenever idealizations are used in modelling. So, take for instance models of fluids. To explain how water flows or how waves propagate in water, scientists will use models based on continuum hydrodynamics that treat water as a continuous, incompressible fluid. On the other hand, to explain diffusion, such as the behaviour of dye after it's dropped into water, then the fluids will be modelled as discrete particles. So we have two ways of modelling water. One as a continuous medium, the other as a collection of particles. And of course, background theories in chemistry assume that the particle model is correct. When we treat water as a continuous, incompressible medium, we are idealizing. The point is just that, taken at face value, we have some models that represent water as a continuous medium, some that represent it otherwise. Or consider stellar models. When modelling the internal structure of the sun, we may represent it as if it were composed of an ideal gas. An ideal gas is composed of randomly moving, dimensionless particles that interact only through perfectly elastic collisions. The behaviour of the ideal gas is governed by the ideal gas law. Our background theories of physics and chemistry tell us there are no ideal gases, though, of course, the behaviour of real gases may approximate the behaviour of ideal gases. So, again, taken at face value, we have models that tell us that the sun is composed of an ideal gas and other models that tell us it's not composed of an ideal gas. We have models that represent it in both ways. Finally, there are internally inconsistent theories or models. This is probably the least common kind of inconsistency. The most famous example of this is the Bohr model of the atom. At least this has been arguably a case of this. So the Bohr model assumes that electrons revolve in stable orbits at discrete distances from the atomic nucleus without radiating energy. However, the model also uses Maxwell's electromagnetic equations, which entail that electrons accelerating in orbits must radiate energy. So in the Bohr model, the electrons both radiate energy and do not radiate energy. And again, that's just part of what's assumed in that model itself. So this is a case where like a single model represents something as being inconsistent. Of course, the Bohr model has now been superseded, but these are just some of the ways in which inconsistencies might arise in science. Prima facie, these are cases of inconsistency, right? So it looks like what we have here is a case where, we have inconsistent objects, a galaxy that both spins and does not spin according to a predicted rotation curve, a fluid that both is and is not a continuous medium, a star that both is and is not composed of an ideal gas. Moreover, prima facie, some of these inconsistencies occur in successful science. The models in these cases are in fact deployed in practices of fine-grained prediction and intervention. It looks like we have a case where there are successful scientific models that nevertheless are inconsistent. Now, the standard view here is that obviously realism is not going to extend to these inconsistent models. The inconsistencies, if anything, raise a problem for realism, because there are many models that even realists will grant are successful, but that also must be false, and that threatens the realist's inference from success to truth. I've discussed this problem previously in my video on idealizations, which I will link on in the comments. But Collivan points out that in principle there is an alternative option here. So rather than taking this as a challenge to scientific realism, we might take it as an argument for belief in inconsistent objects. As the saying goes, one person's modus ponens is another's modus tollens. So the claim is this: realists are committed to believing in whatever is postulated by our best scientific theories. Our best scientific theories postulate inconsistent objects, so realists are committed to believing in inconsistent objects. Now, given the assumption that we ought not to believe in inconsistent objects, we have a challenge to realism. But instead, we could take this situation as a challenge to the consistency assumption. Right? So this conclusion that realists are committed to believing in inconsistent objects, if we assume that inconsistency is out and we shouldn't believe in inconsistent objects, then yes, that's a challenge to realism. But maybe, Collivan suggests, this is in fact just a straightforward argument for there being inconsistent objects. Like maybe we should just reject the assumption that that the world is consistent. After all, science has revealed many surprising things about our world. It has overturned common sense many times in the past. So maybe it also reveals that the world is inconsistent. So this is the general argument, right? We ought to believe that our best scientific theories and models are true. So at least those theories and models that play some role in fine-grained prediction and intervention. But some of our best theories and models are contradictory, so we ought to believe there are true contradictions. Since some of our best scientific theories and models entail inconsistencies, scientific realists are prima facie committed to believing in contradictions. They're prima facie committed to being dialetheists. And maybe they should just embrace that commitment. That's what Collivan suggests. So there's the argument. Let's think about some responses. So one response here is that, well, consistency is not negotiable. We have to obey the law of non-contradiction. This is probably the kind of the traditional view, right? The law of non-contradiction is just a basic law of thought. To believe an inconsistency, to believe a contradiction, is just incoherent or unintelligible. So the law of non-contradiction trumps all other considerations. This is just a basic law of logic that cannot be violated. Well, I mean, obviously at this point, dialetheism has been pretty well developed as a philosophical theory. We have paraconsistent logics for modeling formal reasoning with inconsistencies. Both the kind of philosophical and the logical tools here are pretty well developed for handling contradictions. Now, of course, the standard motivations for dialetheism are things like the semantic paradoxes, as I mentioned, paradoxes like the liar sentence. It's quite another thing to claim that physical objects might be inconsistent, that there could be inconsistencies in the physical world. But we might wonder whether there's really a relevant distinction here. Why would inconsistency in concrete objects be more problematic than inconsistency in abstract objects like propositions? In any case, the key point here is just, okay, so whether you like it or not, dialetheists have successfully put the law of non-contradiction up for debate. It is no longer taken for granted. And so we can't just assume that this law holds in the context of responding to an argument that is explicitly questioning the law. Look, you can do what you want, so I guess you could just assume that it holds, but that's not really going to be a particularly convincing response to someone who has, thought about dialetheism and maybe finds themselves attracted to it and is presenting an argument that is explicitly questioning the law of non-contradiction. I think the point here is just the law of non-contradiction. It's not something that is simply taken for granted. There's plenty of dialetheists who have presented serious objections, and they've developed logics that are capable of handling inconsistent information. Another objection here is that even if we grant that consistency is not inviolable in principle, consistency remains a theoretical virtue in science. So inconsistency clearly counts against a theory. Inconsistency is a good indicator that something is wrong, that there is still more work to be done. And of course, this is exactly how scientists will behave with respect to inconsistencies. Scientists don't simply postulate idealizations like continuous mediums and ideal gases and then just leave it at that. They will try to find ways of de-idealizing the models, or they will try to develop new models that are based on different assumptions so as to remove the inconsistencies. And as we've seen, realism only recommends belief in our best theories, but inconsistent theories and models can never be among our best. When a theory is inconsistent, we will search for a better one. We will search for one that is consistent. So yeah, I mean, okay, maybe in principle, the law of non-contradiction isn't some universal law of thought, but even so, consistency is still a theoretical virtue. And when we face inconsistent theories, we assume that these theories aren't the best, right? We will continue to search for better theories. Okay, so what might we say about this? Well, let's grant that consistency is indeed a theoretical virtue. In itself, that doesn't get us very far. There are many theoretical virtues, and sometimes we have to trade one virtue off against another. So, I mean, different philosophers will give different lists of what the theoretical virtues are. Empirical adequacy, consistency, simplicity, explanatory scope, unifying power, fruitfulness for further research. These are some of the theoretical virtues. But these virtues can sometimes pull in different directions. We might be willing to choose a more complex theory over a simpler one if the more complex theory provides explanations of a broader range of phenomena. Or we might be willing to retain a theory in the face of an anomalous experimental result if that theory has successful applications in a broad enough range of other cases. Or sometimes, as in the cases of idealization, we might be willing to accept models that are inconsistent with background theories if this simplifies the model without sacrificing empirical adequacy. So the thought is, if consistency is merely a theoretical virtue rather than an inviolable law, then there could be cases where other virtues outweigh it, right? There could be cases where we have an inconsistent theory, and that inconsistent theory is among the best, because although the inconsistency is a cost, that cost is outweighed by its performance with respect to other theoretical virtues. Another point worth bearing in mind here is that, in general, in science, belief is only ever provisional. And this is the case also for consistent theories. Even the most well-developed theory can always be put to further tests, and in principle it might be overturned. So, the claim of this objection was, look, for any inconsistent model, it cannot be among the best. We will always assume that there's a better model to be found. But, we might say, well, this assumption that there's always a better model to be found, that follows not from the inconsistency, but that's actually just a general methodological principle that is assumed, in all cases in science. So for any of the models we accept, we must be open to the possibility that better models will be found. And in fact, we must kind of take it as a kind of practical assumption that there are better models out there. That's what, drives continued research, right? Like, even when you think you've got a complete explanation, if you have this sort of methodological principle that there is a better model out there, then that's going to drive further research. And that, of course, goes for both the inconsistent models and the consistent ones. So if we should refrain from believing the inconsistent models on the grounds that better models might be found, then it seems that similarly we should refrain from believing the consistent models for the same reason. So this argument would end up challenging realism in general. It would challenge realism across the board, not just realism with respect to inconsistencies. Okay, another response is to appeal to the distinction between claims about what we ought to believe and claims about what there is. A distinction between belief and ontology. So, interestingly, Conovan himself does not present his his dialetheist argument as an argument for the existence of inconsistent objects. His conclusion is simply that we are justified in believing in inconsistent objects. So, to quote Collivan, he says, "This is not an argument that the world is inconsistent or that the world contains inconsistent objects, just that there were times when we had warrant to believe in such inconsistent objects." And of course, perhaps one of those times is now. So, what we might say is that we are committed to believing that there are inconsistent objects. But this need not entail that inconsistent objects actually exist. And I mean, that's fair enough, right? Like the mere fact that we ought to believe that P, this doesn't entail that P is actually true. It could be that there's strong evidence for a proposition, but still that proposition is false. So suppose that Verity is accused of a murder, but there's no evidence that can link Verity to the crime scene, no fingerprints are found, no DNA evidence, nothing. Multiple witnesses who seem to be speaking freely testify that they were with Verity at the time the crime allegedly occurred. So, I mean, given all of this, you might say, yeah, well, you ought to believe that Verity is innocent, given the evidence. Nevertheless, Verity might still be guilty. Like, maybe the evidence is misleading. So, yeah, the fact that you ought to believe that P isn't going to entail that P is in fact true. Still, I mean, you know, we might say, look, there's something odd about Collivan's move here, because although we can acknowledge that the fact that we ought to believe that Verity is innocent doesn't entail that Verity in fact is innocent, we can acknowledge that, but it would still be very strange to say something like this. We ought to believe that Verity is innocent, but also we have good evidence, good reason to believe that we are mistaken about this and Verity is actually guilty. So it's one thing to believe that P while recognizing that we could be mistaken about P. It's quite another to believe that P while saying that we are in fact mistaken about P. And that seems to be the attitude that Collivan is recommending we take with respect to inconsistent objects. That we're justified in believing that there are inconsistent objects. Nevertheless, we have good reason to believe that we are mistaken about this and that in fact there are no inconsistent objects. I mean, that's a very odd sort of attitude to take. If I come to believe that there are inconsistent objects, I come to believe that inconsistent objects exist. Obviously, my belief in inconsistent objects doesn't entail the existence of inconsistent objects. I could be mistaken, but from my own point of view, it seems like these basically amount to the same thing, right? Like, once I believe that there are inconsistent objects, I'm going to believe that inconsistent objects exist. So, yes, it's not entirely clear what sort of epistemic... So, like, what's the kind of doxastic state that we're supposed to actually be in here? I think that's a little bit unclear. But there's, I think, a more serious issue with this response anyway, which is... Okay, what exactly is the relevant difference between the consistent theoretical postulates and the inconsistent ones? So, if I'm a realist, then I'm going to say, I believe that there are electrons. I take it that electrons exist. Why? Well, because of the remarkable success of the theories that postulate electrons. That's the basic realist claim. Now, Collivan's original question was, why should the realist treat inconsistent objects any differently, right? Like, so where scientific theories are inconsistent, why not just accept the inconsistency in the same way that the realist accepts electrons? And so with that in mind, when we appeal to this distinction between what we ought to believe and what there is, it looks like there are two options here, right? So first of all, we could say that in general, science doesn't tell us anything about what there is. At best, it tells us what we ought to believe, but it doesn't actually tell us anything about what there is. Even with respect to electrons, there's no argument for the claim that electrons exist, merely that we ought to believe in electrons. But now we just seem to be giving up on realism. So if science isn't telling us that there are electrons, then yeah, it looks like is that realism? It seems like we're just kind of giving up that realism. So that's one option. The second option would be to say, yes, science does indeed tell us that there are electrons. But as soon as we say that, then we can push Collivan's original challenge. We can say, well, look, in the same way that science tells us that there are electrons, it tells us that there are inconsistent objects. So, we have this straightforward argument for inconsistent objects. Clearly, Collivan's response, this response that distinguishes what we ought to believe from what there is, that's only going to work if we already have some reason for treating the consistent theories and the inconsistent theories differently. But if we have some reason for treating the consistent theories and the inconsistent theories differently, then it looks like we have a direct answer to the original challenge, right? We can just give a direct answer to the question of what's the relevant difference between the consistent postulates and the inconsistent ones. We need not take any detour through the belief ontology distinction. Okay then, a final objection to Collivan's argument is that we must assume the consistency of the world as a pragmatic constraint in order for science to proceed at all. Consistency can be treated as an ontological principle in the sense discussed by Hasop Chang. So I have a video called Science and Metaphysics where I discuss ontological principles in a bit more detail. I will link that in the comments, but the basic idea I think is fairly simple. Ontological principles tell us the fundamental nature of some domain under investigation, and they tell us the kinds of objects and properties that can exist within that domain. Now, Chang's idea is that some ontological principles must be taken to be true in order for us to engage in particular kinds of practices. So there are some ontological principles that make particular kinds of inquiry or particular kinds of practices possible for us. Now, it doesn't follow that these principles literally are true or that they correctly describe a mind-independent world. I mean, maybe these principles are false. The point is that there are certain activities that we can engage in only if we make certain assumptions, only if we assume that certain principles are true. So these ontological principles have a pragmatic necessity. And the idea is that consistency is pragmatically necessary for science. And that's because consistency is required in order for theory testing to make sense. So here's how this works. In general, in order to test some hypothesis H, we can join H with various auxiliary assumptions in order to derive a prediction P. We then make an observation. And if we find that P is true, this confirms H, while if we find that P is false, this refutes H. And in that case, we have to go back and modify our hypothesis. In science, this kind of empirical testing is the primary method by which we decide between competing theories. This is pretty central to science. This kind of very abstractly described method here. So now suppose that there can be true contradictions. So it could be that P is both true and false. Well, in that case, making the observation that not P, observing that P is not true, that would no longer count as refuting H, because even though we've observed not P, given that both P and not P could be true, the observation that not P doesn't rule out the possibility of P. So it could still be the case that P. So if H predicts P and we observe not P, well, if it could be the case that both P and not P are true, then even though we've observed not P, the prediction, H's prediction, could still be correct. The observation of not P no longer refutes H. I mean, consider the galaxy rotation problem. In this case, we have various theories from which we've derived the prediction that speed will decrease as we get further from the galactic center. But then, we observe that this doesn't happen. And this is taken to refute the combination of hypotheses used in the derivation of that prediction. So to solve this problem, we have to modify those hypotheses. Maybe we're incorrect about the mass distribution in the galaxies, we postulate dark matter. But if we think that the world could be inconsistent, then in the galaxy rotation problem, we might think, well, we've just discovered an inconsistent object. I mean, if that's a possibility, then the observation no longer refutes our theory, because we could say that, look, although the prediction was found to be false, it's also the case that the prediction is true. So there's no need to modify the theory. Actually, the theory entails this prediction, and that prediction is in fact true. So if we allow for contradictions, if we allow for true contradictions, then we just can't make sense of this kind of empirical testing of theories, and that would be pretty disastrous for science. Okay, so a couple of points about this. First of all, recall that Collivan's argument is targeted specifically to scientific realism, to the view that our best theories of the world are approximately true. And there might be a worry here that, if we start appealing to the idea that science is based on ontological principles that have a pragmatic necessity, then it looks like we're shifting away from realism. We're shifting to a more pragmatist account and not a realist account. And actually, so this idea of ontological principles, it comes from Ha-Seok Chang, and Ha-Seok Chang is more on the pragmatist side than the realist side. So at least with respect to the ontological principles, we would have to say that science does not deliver true descriptions of a mind-independent world. Of course, is that incompatible with realism? Well, maybe not, because we might say, well, look, there are certain specific principles that we have to endorse as pragmatically necessary, but, we can still derive beliefs about an independent world from them. So we would still have a kind of realism. So, it's maybe similar to this. In order for science to proceed at all, presumably we have to care about the truth, right? Or we have to, care about scientific inquiry. And so, we might think that in order for science to proceed at all, we have to endorse some sort of principle along the lines of, that sort of tells us that, knowledge is good or scientific inquiry is good. You wouldn't necessarily have to be a realist about that value, right? So if I say that knowledge is good and that this is what drives scientific inquiry, well, I wouldn't have to be a realist about the claim that knowledge is good in order to think that science can deliver true descriptions of the world. So, there might be some tension between realism and this view of ontological principles as pragmatic necessities, but there does seem to still be scope for some kind of realism here. Okay, but putting that point aside, there's, I think, a more serious concern about the idea that consistency is a pragmatic necessity. So according to this argument, this pragmatic necessity argument, we must assume the consistency of the world in order to test our theories. But arguably, theories are ultimately only ever tested against what is observable, against what is experienced. So when we derive a prediction from a hypothesis, that prediction is only going to be of any use in testing the hypothesis if it concerns something that we can actually observe, something that we can, if we can go out and check, and see whether the prediction is true or false. So arguably then, what is pragmatically necessary for theory testing is the consistency of the observable world, the consistency of perception. It's not so obvious that we need to assume the consistency of the world beyond the observable. And notice that when we think about models of water that treat it as a continuous medium, or models of the sun that treat it as composed of an ideal gas, these are theoretical postulates. We can't observe these things anyway. Even with something like the galactic rotation problem, we can observe galaxies, but we don't observe galaxies spinning. That's an inference that we make on the basis of things like we can look at the light from galaxies and measure things like the Doppler shifts, and then that allows us to draw conclusions about how fast parts of the galaxies are spinning. But of course, if you just look through a telescope and look at the galaxies, they just look completely still. So the point is that, in all of these cases of supposedly inconsistent objects, then they're actually not, the inconsistency is not observable. So the fact that the observable world is consistent doesn't in itself entail that the world beyond the observable is consistent. And of course, realists will already acknowledge that unobservable things may have very different properties from observable things. I mean, we can't, literally observe laws of nature. We can't literally observe properties of particles like spin or color charge. And there isn't, I mean, I don't think that, it's like there's not anything exactly like spin or color charge that you can literally see. We can't observe quantum superpositions. And again, there's nothing really in the observable world, there's nothing exactly like a quantum superposition. So unobservable things can have quite different properties from observable things. And so, maybe, right, that Collivan would say, well, why not inconsistency, right? Okay, yes, the observable world is consistent, but maybe beyond the observable there can just be inconsistencies. Indeed, we might think that the realist has independent reasons for supposing that the observable world is consistent, which is, well, nobody's ever observed an inconsistency. And for many people, it's hard to imagine what it would even be like to observe an inconsistency. So yeah, I mean, look, I know what it would look like for a galaxy to spin. I know what it would look like for a galaxy not to spin. But what on earth would it look like for it to both spin and not spin at the same time in the same sense? A lot of people would say that's unintelligible. So the idea is, look, realists should treat inconsistencies as unobservables, just as she treats quarks and electrons and the laws of nature as unobservable. Inconsistency is postulated only in the theoretical objects, not in what we observe, not in what we experience. But in that case, it looks like there's no obvious threat to theory testing, since the observable world is consistent. When a hypothesis entails that P, and we observe that P is not the case, then we can confidently reject that hypothesis. So yeah, arguably, all we really need to make sense of theory testing is that the domain about which our predictions are made is observable. But in domains beyond that, there's no need to assume it's not a pragmatic necessity that we have consistency. So, well, there you go. That was Collivan's argument for dialetheism, an attempt to argue in favour of dialetheism from the empirical sciences, from realism to dialetheism. And I'm going to leave that there. Thanks for watching. See you in the next video.